In this video, we're going to be talking about solving polynomial inequalities. The polynomial inequalities that we're going to have need to be set either less than or greater than, less than or equal to, or greater than or equal to 0. And what we're going to do is we're going to take sort of a graphical approach to solving these polynomial inequalities. The graphs that we will be drawing will actually only be two-dimensional. Well, they'll be one-dimensional, I'm sorry. We're going to draw them on a single number line, with the number line representing the x values that we get for the solution. But let me show you a little bit about the graph of a polynomial equation and what that has to do with the inequality aspect here using a two-dimensional graph. So let me just grab this one kind of out of the margin. All right, this particular polynomial, x squared plus 5x minus 14, you can see the graph that we have here that shows just a representation of the solution set of that particular polynomial. The shape of a quadratic graph is called a parabola. It makes sort of a U shape. But what I want you to notice here really are these 2 points where the graph crosses the x-axis. Okay, those 2 points right there are called critical values in the context of what we're doing in this section. And what they are doing for us here is they're showing us where the graph crosses the x-axis. So this is the points where the graph would shift from being above to below, or from below the x-axis to above the x-axis, okay? Now what that has to do with inequalities is what we're checking here are the y values, whether or not the y values for certain x's are bigger than 0 or smaller than 0. And so if we're checking around these critical values, what we'll see are y values that are positive or greater than 0, and that y values that are negative will be the less than 0, okay? So as you can see in this picture, essentially what's happening is the graph, as it comes in from the left, is all above the x-axis. So all of these values, all the x's that you plug in here into this polynomial would give you positive y values. Same thing on this other side, over here on the other side of 2. All of these x values that you would plug in would give you positive y values on this side as well. So in both of these areas, you have x values that create positive y's, okay? And so that's where your polynomial is actually greater than 0, is where we are above the x-axis, okay? And then the area that's below, which would be all of the x values between this -7 and the 2 that you see here, if I plug any of these x's in, I'm going to get a y value that's down here below the x-axis. So this is where this polynomial is actually less than 0, is in this area right here. Now, we're not doing the two-dimensional graphs because we're not quite to the sections on graphing polynomials just yet. What we're going to do is use a number line to find the critical values and then to test points on either side of the critical values and then between them to see where the graph would be bigger than 0 positive, okay, or less than 0 negative down here, all right? So we won't use a two-dimensional graph. It's just a good illustration of what's going on. And in a second, when we do an example, I'll have this graph along with the sign graph that we're going to draw, and we can kind of compare those two and see what it looks like. Okay? All right, let's move into the steps. You start out with your polynomial or quadratic inequality. Your first step is to get 0 on the right-hand side of that inequality. You may have to move a term or two to make that happen. Then find the critical values by setting the polynomial equal to 0 and then solving for x, okay? So what's going to happen here if it's polynomial, quadratic, cubic polynomial, which you won't see anything any larger degree than that, you'll need to set equal to 0, factor, or use the quadratic formula if it happens to be quadratic, and get those critical values. The next step, we're going to draw a number line and we're going to mark the critical values on that number line. Okay, critical values, okay, sorry, it wouldn't let me switch back to the other slide. So the critical values are the same thing as the x-intercepts if you were to graph the polynomial in two dimensions. In two dimensions, sorry, on the x, y axes. your next step is to choose a test point for each one of those intervals. Then you plug that test point into the polynomial and make a note of the sign of the number you get. When you plug a number in for x, the number you get out is actually a y value, even though we haven't started talking about equations in x and y yet. That is really what you're getting, is a y value, okay? So you'll make note of the sign of the number that you get each time you evaluate with the test point. Then, depending on what signs you see, when you do that, if your polynomial was greater than 0, then the positive intervals are your solution, okay? If your polynomial was less than 0, the negative intervals are going to be your solution. All right, so those are the steps, and they'll make a little bit better sense as we go through the example that we're fixing to do on the next slide. Okay, so the inequality that I've chosen for us to solve here is a fairly simple quadratic, just to make it a little easier for us to find the critical values. I picked something really easy to factor. So your first step, remember, is to get 0 on the right-hand side. Well, that's actually already done for us. I don't have to move anything. But if I had another term, let's say this had been a 6 or something like that, I would need to subtract that number from both sides. Okay, so we're going to factor this little quadratic that we've got. And if I factor the difference of two squares, then I'm going to have x minus 3 and x plus 3. Okay. We set those factors equal to 0. So let's see, we've got x minus 3 equals 0, so x is going to be 3. And x plus 3 equals 0, so x is going to be a negative 3. Okay? Those are our two critical values. Alright, so the next step is to draw a number line and mark those values, okay? So what I'm going to do, I have a picture of the graph of this little polynomial. I'm going to pull this down, scoot up just a little bit. Well, now it's grabbing everything. Hang on. I have to take me just a minute to get this grouped back together so I can stretch it. Okay, now we're a little bit better. What I'm going to do is I'm going to draw the number line on top of the x-axis of this graph, because the number line is actually an x-axis. Okay, so if we go back up here, our inequality is greater than or equal to 0. I was just going to go ahead and write that so that we've got it kind of sitting in front of us. Right there. And we have 2 points that we need to mark. Let me go ahead and draw in a number line for us on top of the x-axis. Okay, so you can see a little bit better exactly what's going on in 2 dimensions too. The two values that we will mark are negative 3 and positive 3. Notice that those two are the x-intercepts, as we've already talked about, of the actual graph of the polynomial. Okay, those are also our critical values. And what we're going to do now is pick a test point outside of each critical value and then between the two critical values, so that we can then plug that back into the polynomial, either in the general form that you see here with the x squared minus 9, or in that factored form. Either one's fine. So let's pick a couple of test points. I'm going to choose negative 5 just to give myself a little bit of room in there. Normally I would just pick like a negative 4 right on that side of it. And then I'm going to pick 0. Okay, so there's 0, there's negative 5. And then I'm also going to pick maybe positive 5 over here. Okay, and what I usually do is I mark off the intervals a little bit better that the critical values have created. I usually put little fence posts up, or whatever you want to call them, to kind of mark those off. We're plugging the test values into that x squared minus 9 and checking the sign that we get, whether we get a positive or a negative sign, okay? I think you can probably tell from the graph exactly what's going to happen, because we talked about this already, what happens with a polynomial like this. But let's go ahead and do it anyway, because you're not always going to have that two-dimensional graph behind you when you create this, okay? So what I would do is I usually like to use the factored form, which I'm going to write out down here because we're getting kind of crowded around the graph itself. You don't have to use the factored form. You can use the x squared minus 9 if you'd rather. And we plug those test points directly back into this. So if I plug in that negative 5, that's going to give me negative 5 minus 3 times negative 5 plus 3. Okay, let's see what that gives us. Negative 5 minus 3 is negative 8, and negative 5 plus 3 gives me negative 2. So that's going to give me a positive 10. So we get a positive interval right there. You can use one big plus or several little pluses, or you can just write positive across there. That's fine too. Now we're going to plug 0 in, so it's going to be 0 minus 3 times 0 plus 3. So that is negative 3 times positive 3, or negative 9. So this interval in the middle is negative, and you kind of already knew that was going to be because you can see the graphs below the x-axis showing you negative y values there. Plug in 5 in, we get 5 minus 3 times 5 plus 3. So I get positive 2 and positive 8. And I messed that up a minute ago. That's actually 16, not 10. I'm so sorry. Hang on one second. Let me see if I can get rid of it. This is going to blank out the grid too, but that'll be okay. I just wasn't thinking. Just was not thinking. So, positive 16 instead of 10. We do still have the right sign. The truth is, you really don't care what the number is. You do want to get it correct, okay? So I'm not saying that I'm excused for missing that, but the sign is really what you want to know. You don't really so much care about what the number is. So now we go back and we take a look at what our inequality was, what we want. We want the values for x squared minus 9 that are greater than or equal to 0. So we want positive values. Okay, so we want to know the positive numbers when we plug certain x's in. When do I get a positive value for x squared minus 9? Okay, and that's what we were looking for on this number line down here. That's going to happen when x's are less than or equal to, because it's less than or equal to, negative 3, and where the x's are greater than or equal to positive 3. Okay, so it happens here and it happens here. Between them, we're less than, but outside, we're greater than. We're plus. Okay, so we're going to grab those two intervals, and you can show it on the graph too if you like. Okay, to graph it, we would just put brackets at those two because it's or equal to. And then we graph right along the number line just like this. Okay? And to write in interval notation, which is the way these questions are supposed to be ended, what we'll do is we'll take positive infinity, or negative infinity rather, because we start to the left, and go to negative 3, and then union that with our other section, 3 to positive infinity. Okay? And that is your answer. All right, now I know all this is a bit cluttered because I've got that graph behind us there, but I did want you to see, kind of how that goes with it, how they go together. You don't have to, obviously, you don't have to put the two-dimensional graph behind the number line. It's not an absolute necessity. Sorry, I didn't mean to leave that line right there. I was trying to pan. Okay, all right. Let me see if I can get rid of that grid and y'all can look at it without. Okay, I moved the grid that was behind our number line off to the side so there was a little less thing to clutter things up. Okay, so I think you can see it a little bit easier now. We've got the critical values at 3 and negative 3 marked. That's right here and right here. Our test points were 5, 0, and negative 5. Okay. So we've got the calculation from plugging the test points in. That's down here for the first one. We got a positive 16. Here for the middle, we got a negative 9, and I marked the sign up there. Then we got another positive 16 when I plugged in positive 5, and I marked the signs over there, okay? Our solution was from negative infinity to 5, negative 5. I'm sorry, negative 3, excuse me, it's sitting right there on top of it. And then positive 3 to positive infinity, okay? So that is what we're looking at here, and there's our answer right there.